Okay, so once again, welcome to this session titled "All Your Specs Are Belong to Us." François, my colleague François and myself, Dominique Gazel-Mathieu from WCC staff, thought we would use TPAC as an opportunity to look at how specifications are developed today for the web platform, what tools exist around them, what ecosystem of tools exist around them, and also what improvements we think would be worthwhile bringing to that ecosystem, both for the benefits of spec editors, implementers, people active in using the web platform, but also for the benefits that can be derived for developers and hopefully what I mean by that will become clearer as we go through this presentation. So where are we coming from? Why are we even bringing this topic? If you look at how the open web platform is developed today, you're looking at a very diverse set of communities and groups working together. More specifically, there are at least 26 working groups in WCC that are developing specs meant for web browsers. At the very least, 9 community groups, but possibly more. For those of you not familiar with WCC, working groups do formal standardizations, whereas community groups do more pre-standardization and incubation work. So on top of that work happening in WCC, there are 15 work streams happening in the WebIdLpedia, including notably the HTML, DOM, and fetch specifications. The core of the JavaScript language is developed in ECMA by TC39. So that's a big piece of what people developing for browsers use on a daily basis. And on top of that, you should at least count also the WebGL work done in the Chronos group. And that may be a subset of all the technologies, standard specifications that are used to define what developers use on a day-to-day basis for building web pages and applications. And that diversity is great. It's a reflection of the diversity of communities and interests and so on that back these technologies. But we are all working together on a single platform, so we cannot really afford for that diversity to have a detrimental effect on the consistency of the platform. I like this so-called Conway's law, which says any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure, which basically means that any product or solution you developed will developed around the boundaries of the subgroups that developed it. And I think if you look at the way the web platform gets developed, you do see quite a bit of that law in application, where the fact that this or that technologies take this or that approach, builds that or that way, will be in many cases a reflection of the culture or the background of the group who developed it. And in general, if we want to keep the consistency high despite that diversity, if you take Conway's law to heart, it means we need to improve the communications across these groups to ensure that the design patterns flow better between the various technologies. But all these groups work on their own pace, their own times, and their own rules. So communication basically needs to be asynchronous and either decentralized or distributed. And for anyone who has put in place asynchronous distributed communication system, you'll know that they're hard to get it right. But the good thing is that although tools cannot solve the problem on their own, tools can help make the problem at least a lot more tractable. And that's what this presentation is trying to show, both in terms of what we are already doing in the open web platform space, and also highlighting things we could or should be doing to make that overall process smoother, easier, and more natural for everyone. So I think one core trend that anyone who has been involved in web standardization for the past decade is that we've seen a lot of inspiration on the way software has been developed, applied to how standards are developed. The notion of evergreen standards or living standards, the notion of using GitHub as a way to get contributions from as many people as possible. The notion that there needs to be a lot more specificities in, for instance, how algorithms get defined. And different people will have different opinions on whether all of it was good or not. But I think in terms of the structure that it has brought to the platform and its ability to grow into new spaces, there is probably broad consensus that this was a needed development. And one of the way we think specs can go further in that direction is by looking in more details into the dependency management. Again, for better or for worse, dependency management is a pretty hot topic in the space of software development, with lots of packaging system, registries, systems to reduce or subset these dependencies. But so far in specs land, dependencies have been managed in a very coarse fashion. You basically say spec A has this normative dependency on spec B and spec C. But we're talking about specs that for some of them are several hundred pages long. And so saying that a given spec, for instance, has a dependency on the HTML spec isn't really saying much at all. I guess there must be very few specifications that don't have a dependency on HTML. And you could say, well, that doesn't really matter, but in fact it does, because a dependency in spec as much as in software means that if the piece of spec you're depending on changes, you may need to adapt your own spec as you would adapt your own software to reflect that change. And right now, this is managed in a very ad hoc fashion. Sometimes you'll determine that something has changed because a link no longer works, or someone implementing will find that it doesn't really make sense anymore. And it kind of works, but it's certainly not smooth or seamless in any fashion. And one of the things we want to argue today is that we now have the infrastructure and the tooling to make that a lot more precise and a lot more useful for groups and spec writers. And the model we want to go towards is the one illustrated on the right-hand side of the slide, where we show a lot more granular cross dependencies between specs, where it's clear that spec A depends on this particular definition in spec B, this particular ideal fragments in spec B, this and that algorithm in spec C, and so on and so forth. It also shows that not everything that is declared in spec B or in spec C is available for referencing. Only a subset of the definitions, whether they are abstract or ideal or anything else, only a subset of those are expected to be referenceable. In software land, you would say these are the exported interface of your modules. And again, the point I'm trying to convey here is that we have a lot of the infrastructure to make this possible today. There is still some work to make it happen, but we do see quite a bit of value in getting there. And to illustrate that value, I want to bring light on the ecosystem that exists around this spec development environment. If you've been involved in writing or contributing to specifications in WCC and in WebIdLpedia, you will know that most of them are developed using two main authoring tools. One is Bikeshed, the other is Respec. And because of the many improvements that have occurred in these tools over the past years, we are now able to bring a lot more of this added value to the specification development effort. Part of it is because on top of these authoring tools, there are a number of tracking tools that have emerged. And we'll go into more details on the various bits of this diagram. But again, if you've been involved in writing spec, you might have heard about specref as a way to create references to other documents. You may be less familiar with browser spec or the WCC API or Shepherd, but again, we'll come back onto those. They play an increasingly important role in making sure this full ecosystem works reliably. And one particular project that Francois and I have been working on the past few years with an increased focus the past few months is called Refi with another project called webref that exploits Refi. And Refi is a tool that is able to go through all of the specifications developed for the web platform, whether they are WebIdLpedia, WCC, YCG, Chronos, and soon hopefully as well TC39. So that tool crawls all of these specs and tries to extract as much reusable data out of these specifications. More specifically, it extracts all the IDL fragments, so the interface definition language fragments that define web APIs for JavaScript. It extracts all of the formal definition of CSS properties and values, but it also extracts the pieces of the specs that are marked as definitions with the ability to identify whether they are meant to be exported. If you recall my previous discussion about whether something is meant to be reused by another spec or not. And it extracts also which spec references which other specs. And what we've seen emerge out of this data that we extract on a regular basis is another collection of tools, some of which meant for spec developers, but many of which meant for the broader web developer ecosystem that are able to exploit this data and make use of it in many fashions. We will discuss some of them, but I think the key message here is that we don't even need to know about all of them. We don't even need to understand all the use. It's clear that there is a demand from this web developer ecosystem to get access to this data. And so we should make sure going forward that we make these extractions possible, we make them more useful, more powerful, and we see tools emerging out of the data we provide. So let me see, is there anyone in the queue? No, so I'll move forward. So I mentioned a number of tools, and so I just wanted to give a quick overview of the tools that are already available today or are emerging. I mentioned specref, which is this tool developed by Toby Langell, which enable specs to reference each other very easily without having to keep track of which version they are at, which status they have, and so on. Again, if you've contributed to the LCC specs, you might recognize this double square bracket syntax that can be used to do this automatic referencing. And spec-ref gets automatic updates for the most part. There are still parts that require manual updates, particularly around community groups, but this has clearly grown as a fundamental piece of how the LCCs and what we specs for that matter keep track of each other. One piece that has emerged more recently over the last year or so, I guess a bit more now, is the ability to not only reference specifications, but as I alluded to earlier, reference specific definitions made in other specifications. So right now that is based on this other spec processing tool called Shepherd, done by Peter Linz. But the work François and I have been doing on Refi and webref hopefully will complete that with a lot more data and a lot more up-to-date data. And again, that compilation of definition is used in specification, so that instead of saying I'm referring to this definition in this specification at this URL, you just use a specific syntax that will vary whether you're referencing, for instance, to an ideal token or to a definition. We've given a couple of examples on the slides. But once you do that, you basically get all the links done for free instead of having to use links that can break. And the tools will also warn you if you're referencing a definition that doesn't exist or no longer exists, which can help with both spotting typos, but also spotting changes in definitions that, for instance, would have been removed. To make that mechanism really useful, we will need groups to step up in terms of making sure they export all the definitions that they think their specs should expose. And conversely, that they do not export definitions that they don't want other specs to be able to reuse. If, for instance, you think that a particular definition is too specific to the context of the spec that it shouldn't be reused, and that's an important message to convey. That also means that there may be negotiation between groups in figuring whether this algorithm, this definition should be exported or not. But from our experience, these negotiations are actually useful coordination point, useful anchors to this asynchronous discussion paradigm that I was alluded to earlier. And the nice bit about this formal approach to definition is that it also provides very useful anchors for other tooling on top of the specs. You may have seen emerge over the past few months specifications which shows whether the feature in a given section is being implemented in what browsers. And that is done by re-exploiting data collected by the MDN WebDocs project, which is a portal of documentation on web technologies, and which includes, for as many technology as possible, manually collected data about whether a given browser supports a given feature at a given version of the browser. And so being able to know that the feature is being defined at this specific place in the spec allows this kind of automated annotation. Another, I think, pretty impressive change that has occurred over the last year based on this automatic extraction of data I was referring to. Because now we are able to get the latest ideal automatically extracted from each and every spec. These ideal fragments can be automatically brought to the Web Platform Test Project, which is this huge test suite that is used by browsers, both as regression and conformance test suite, to ensure the conformance to web platform specs improve over time. And using a semi-automated process set up by Philipp Gegenstadt, we are now able to keep that set of ideas automatically updated and reviewed for testing purposes, which means that anytime a spec is being tracked, then it gets automatically tested across the latest version of each of the major browser engines. I mentioned earlier the MDN browser compat data, which shows which browser implement which feature of the platform. And that data is also well positioned to benefit from this automatic extraction we're doing, because they need to know which feature exists. They need to know where it is defined. They need to know when it evolves. And right now, or at least so far, that had been done as a manual process, which of course is not ideal. But once you are able to build on this extracted data, then you can at least seed the information about which feature needs to be documented. And in the best cases, you can even automatically test whether a given browser supports the said feature or not. Or if not completely automatically test, you can get early results that can be human verified afterwards. And that's what the MDN BCD collector project, which again, we use the data we extract from specifications, is in the process of accomplishing. And you may or may not be aware of MDN browser compat data. You're very likely have heard about caniuse.com, which nowadays, for a big part of its data, we use the data exposed in MDN BCD. So again, being able to extract this data, exploit it, has a very deep repercussion in the developer ecosystem. I think very few developers don't use either BCD or caniuse on a most likely daily basis to know what they can rely on in the development efforts. Another tool that you may have crossed if you've been involved in spec writing, spec editing, developed by Kagami Rosilite, is this tool that will automatically fix WebIDL across specifications when there is a change in the WebIDL definition itself. For instance, recently, the type that was known as void has been renamed undefined. And given that there are probably 200 or 300 specifications that use WebIDL, getting that type of change adopted used to be really difficult, painful, and challenging. And it isn't quite yet completely seamless, but nowadays, thanks to that amazing tool, we can get pull requests submitted across a very large number of these specifications automatically so that they catch up with the latest syntactic change in the WebIDL spec. And that again is based on the list of specs identified by the processing tools. Another project from Kagami that I thought was interesting to mention. Some of you may know Typescript, which is this variant of JavaScript, which use stronger type annotations to help developers keep their code correct and clean. And because TypeScripts need typing, getting this type automatically derived from the WebIDL typing that we developed for web specifications sounds like a really good reuse of that data. And that's what is being explored right now in the pull request link from the slide, having basically all web APIs automatically typed using the WebIDL annotation. And again, that is based on this automatically data extract from webref. And I mean, TypeScript, I guess, is a pretty popular variant of JavaScript nowadays. So again, bringing all this work we are putting in formalizing our APIs and making it available to the broader developer ecosystem, I think is a really powerful approach to our work, increasing its impact significantly. A smaller tool that I developed a few years ago, again, based on this automatically extracted data, is called WebIdLpedia. Basically, it lets you review all the interfaces, dictionaries, enum defined across the platforms. One reason for that is, as spec writer, if you can reuse the naming conventions that have been used in other specs, that's always good. If you can review it, that makes it much easier. It can also help with figuring out which specifications are extending a particular interface. So if you're changing an interface, knowing which other specs might be affected, you can do that through this tool. And every so often, we've seen another set of tools that have emerged that are reusing this data. For instance, the fact that we're exposing the CSS grammars or the ideal grammars have helped with building first testing around the platform to generate automatic tests to make sure the implementations are either correct or resist to crash when the input is not exactly correct. You can also use it to build validators. And again, there are probably many more use than the one we can think of or that we need to think of. And this is leading us to, I guess, our plea for those of you that are involved in editing specs or contributing to spec editing. We've seen huge value out of this extraction work. We think there is a lot more pending value across formalization of the definitions in specs. Right now, there are still a lot of ad hoc conventions in specs. Not all spec are aware of this distinction between what has to be exported or not, what has to be marked as a concept or a different type of definition. Because not all spec have done this, there are also a lot of legacy usage on how you reuse definition from other specs. So I guess this is a heads up if you're in a group that we will probably be pushing for upgrades in the specifications in the months to come to clean that situation up. With the goal of providing a lot more visibility in this cross dependencies management I was referring to earlier. What we want to enable is that whenever, for instance, you plan on removing a definition from your spec, that you be able to figure out which specs were using it automatically, maybe then negotiate with the spec editors to see what new definitions they should be using. And that's true for definition in general, but there are some definitions, for instance, formal algorithms that expect a specific set of input and output. And right now, there is no way to track when an algorithm expects a new output or a different type of input. And that we think we can automate using this well-structured approach to definition tracking. And in general, we think that getting this more fine-grained map of which spec depends on what specific pieces of which other specs can help a lot of the discussions around the maturity of a given spec, in particular in the context of the WCC process, understanding whether a given spec is stable enough to get the recommendation label. We think there is also a lot more opportunities around integration with BCD browser compat data. And so again, bringing more visibility for developers about what's cooking in the platform, what's being implemented, what may not be implemented so quickly. One way we are looking at to make all this data more usable by other tools, other software projects, is by packaging it. We've started building NPM packages for the ideal fragments that we extract from specifications. We are hoping to do the same for CSS definition as well shortly thereafter. And as we extract more data, more definitions, more value out of the specifications, we would be trying to package it again to help other tools evolve on top of that ecosystem. I also wanted to take the opportunity to highlight the fact that a lot of these projects are done as spare time projects. Not all of it, but some of it, and not all the people that are involved on this are doing it on an employment basis. So in particular, I've linked to 2 open collective if you want to support both spec infra, which is behind the specrif tool I was alluding to, or Respec, which again is one of the major tools used by many WCC groups. You may have seen a few months ago this XKCD drawing that illustrates the issue with a lot of the open source infrastructure nowadays on the internet, where a lot of it might look very stable and robust, but if it all depends on a single person doing work on their spare time, then it's not just as robust as it should be. And so you could contribute to this open collective, but we're also very much looking for motivated people to join us in building that vision that I sketched earlier, and working with the various specification writers, with the various groups in adopting that approach, bringing their specs up to date with the latest practices. So if you're interested and willing to help, do absolutely get in touch. And to finish these presentations, we also had a few questions that may serve for the discussion part, although we're also happy to take any other remarks or discussion points. If you're aware of other tools in that ecosystem I was describing, it's useful for us to know, in particular, as we're looking at doing this packaging, understanding the requirements that the packaging need to follow would be really useful. There are other data that we should extract from specification, other scenarios that these tools could be helping with that you're aware of. When we are looking at this finer grade dependency map, do you have ideas on how you would use it if you're developing specs? Sometimes we do get pushback on some of the changes we're trying to get groups to adopt. So again, if you have feedback on whether this value that we're seeing emerging is indeed worth the efforts from groups, that's useful. The other thing we noted is that I think we've seen a lot of really interesting evolutions among this tool ecosystem. It's not clear to me, at least, that most of groups and editors are aware of this evolution. And so we were wondering if you had suggestions on what to do beyond organizing an ad hoc TPAC breakout session. specprod@wc.org is the mailing list where at least a subset of the editors contribute, but it's not clear that it has that much traction with editors. And we have also more fine-grained discussion points about what kind of definitions, what kind of definition types we should consider, but that's really only if people are really interested to that level of detail. I'll stop the recording now so that we can move to the conversation part.